He was going to point, though, when you were ready. Ready?
Going.
All right. Hey, guys. Ready to start? All right. So this talk is about both, how you would use Ansible. I'll explain what Ansible is. Have you anyone here who do not know what Ansible is? Never used it, don't know what it is, etc. Okay. Are most of you guys on the security team side? Or are you guys operations, or are most of you on the security teams? Mix? Okay. So yeah, we'll talk about both for the offensive security and defensive security with Ansible. So a little bit about who I am before I start. So I'm of course I'm from Red Hat. I've been at Red Hat a little over 4 years. I actually today what I do is I do security technical strategy and evangelism across all of Red Hat's portfolio. So helping our customers understand the built-in security technologies that we have inside Red Hat. Of course, we're not a security vendor in terms of we don't sell security products, but we have security built into our entire portfolio from our operating system up. I spent 3 years as a senior cloud solutions architect at Red Hat, supporting our U.S. government customers. So I was working with various different agencies as they were looking to implement our cloud technologies, and many of them, of course, from public sector. They were they were very concerned about various different security challenges that they had. So I'm not going to go into more about kind of my background. You guys can stalk me on LinkedIn if you really want to know. But I'm going to give you some fun facts about myself. So first of all, my very first job ever was actually working at my parents' restaurant. That's my father. The way we immigrated to the U.S. is my dad's a chef. He has a very specific cuisine that he cooks, and that is Korean Chinese food. This is Chinese food that you will see when you go to Seoul, South Korea, or anywhere in South Korea. If you go there and go, what's General So? Can I have General So's chicken? They'll be like, who's General So, and why does he have a chicken? They won't know what you're talking about. So this is he's making handmade noodles over there. So this is handmade black bean noodles, and it's very similar to northern Chinese food. Beijing has handmade noodle type of thing, but it's Koreanized. It's not the same. It's we Koreanized. And Chinese cuisine is very interesting because wherever you go, even we, Americanized it. In India, they Indianized Chinese food, right? And we did the same in Korea. We Koreanized it. So this is the skill he brought to the U.S. And this is what he opened one of the very first Korean Chinese restaurants in the Washington D.C. area back in the early 80s. That's how we immigrated to the U.S. So I was a baby back then, and he opened this little 30-seat, 20-seat restaurant. That's pretty much what he did in the 30 plus whatever years, the 20 plus years. Now he's retired now, but the handmade noodle, he makes it. He's shorter than me. He has to wear kids clothes and stuff because he's really petite. But this handmade noodles, they're heavy, and trying to stretch it and pound it to make noodles, it's very tricky. I've tried as a kid. It's pretty much impossible. But he's like a machine. He's boom, 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 and he's already done. Anyway, that little 20, 30 seat restaurant sent me and my sister actually to Carnegie Mellon University. That's where I went to school. That's where I studied. I went the traditional engineering route. I actually got a degree in electrical and computer engineering. I thought that I wanted to be a processor designer. I actually became one. That's what I did for the first 5 years of my career at IBM, which I find very interesting because now I'm at Red Hat acquired by IBM. I'm going back. So to me, IBM stands for I've been moved back to IBM. So I actually worked on the IBM Power and Z microprocessors over there, working on the core microprocessor from instruction fetch to fixed point or whatever. For 5 years, I worked on various components of the core microprocessor. So when Meltdown and Spectre came out, I found it very ironic because that's what I worked on parallel execution and things like that, instruction execution. So that was kind of ironic to me. When I'm not at Red Hat or working and doing nerdy stuff and technical stuff, what I usually do is I have a therapy dog. Her name is Susie. This is at Washington Dulles Airport, and United, we have a partnership with them, the therapeutic organization that she's with. And so United's like, please come like during like really high traffic times, like, holidays, July 4th, Christmas, that kind of thing. And so what happens is like the flights may get delayed or whatever. And so basically what we do is we go to the passengers and say, oh, would you like, we noticed that you're delayed until tomorrow. Would you like to pet a dog? And have them pet my dog and things like that. It actually works. United's, I find them should be pretty much a genius for doing this, because 1 minute they're pissed and the next minute they're like, oh, smiling. I don't want to get on the flight. I want to pet my, your dog, that kind of thing. So another thing I do with her is maybe once a month I go out to the DC public libraries and the kids read to her. So, and many of the kids who come, they're autistic. So, parents tell me that they don't speak all day or whatever. And then, but I would never know that because they're like laughing and petting my dog and things like that. So this is a lot of fun. This is what I do outside of Red Hat. Okay, so getting back to business. So basically what we're going to talk about, as I said, is, I'll introduce Ansible to you. I'll introduce why it's exploded in terms of an automation language. I'll talk about, why would you want to use this for not only defensive security, which has lots of good use case for, but also offensive security, like you're a pen tester or a hacker or that kind of thing. And I'll give you some examples to, really illustrate how you would do this with real use cases, what I've seen our customers do, that kind of thing. And then kind of talk about, how Ansible is very, very strategic at Red Hat in terms of it's actually included pretty much almost everywhere in our portfolio, from our operating system to some of our automation, some of our like our various different the portfolio and the automation portfolio, and the various other places. And then I'll show you like some actual real customer implementations and how they used Ansible for security. And then just additional resources and then Q&A. All right. So Ansible it's the automation language, right? But it's a way that you can do automation without actually writing any code. And it's kind of like, okay, well, I want to have the same power of what a code can do, like a Python script, without actually writing code. This is all YAML based, right? It's a markup language. It's super easy to learn, therefore, right? Because it's not actually a programming language. It's like you don't have to worry about like C or C++ where you're trying to dereference pointers, or like worry about memory management, and or even it's even easier like than dynamic language like Python or Ruby, right? This is YAML, so anybody can learn it. If you know JSON, if you know XML or any sort of markup language, you can learn it really easily, like over a weekend. Tower is the enterprise version of Ansible, and we'll talk about that a little later. So this is, as you see here, it's very simple, right? Because again, there's not a big learning curve, because this is not a standard true programming language. This is very easy to learn, yet it has the power of a programming language. And it's also agentless. You don't have to worry about having to update the software, all the other problems that an agent might bring, right? Because are there vulnerabilities in this agent, that kind of thing. So that's at a high level what Ansible is. Now the other thing is, so this is another very powerful capability of Ansible, is that it allows everybody to speak the same language. So when I was a cloud solutions architect, I was at a customer in Tennessee, and they said the operations team was telling me, they're writing their scripts in Bash, and the Windows team is doing PowerShell. Networking team, they don't know what they're doing. The automation team started to mess with some proprietary scripting languages. I can't remember if it was VMware or it might have been HashiCorp Terraform. So they have proprietary scripting languages, and everyone was doing their own thing. The minute that guy leaves, who knows how to write that code in whatever that proprietary language is, now he is stuck. They don't know what changes were made, and then there's this huge wait while they try to replace him to be able to pick up where that guy left off, that kind of thing. So now with something like Ansible, everybody can speak the same language. This is giving you that consistency, giving you that repeatability, the ability for everyone to share and have all of their automation behind something like source code management, like GitHub. So this is the idea. Okay, so now let's kind of move on to why Ansible for offensive and defensive security. So for moving with Ansible, so I want to give some credit to one of my teammates who is not here. He's actually the Chris Grimm and from Red Hat, and he actually came up with all the content you're about to see for the offensive piece. I put all the content and created all the content for the defensive piece, but this offensive content is actually his. So the idea is you're living off the land, right? You're not doing anything sketchy. You're doing SSH using WinRM. Right? This is tools that are already in place, right? Protocols, SSH, WinRM, Python. I told you that in the back end, Ansible is actually Python. You're readily capable of targeting Linux or Windows systems because Ansible can manage it's an automation language not only for Windows, Linux, but it's also for Windows. It's also for devices like Cisco networking devices. And like I said, this looks like legitimate traffic to a sysadmin. Most of the time, like the IDS, IPS type of tooling out there, it's becoming more sophisticated in the sense that it's able to detect specialized malicious software, right? But here, you're living off their land, you're blending in, you're doing things like a normal system administrator would do. So that's why it's a great use case for the offensive side of security. For defensive, this is the benefits of just Ansible in general, the ability to not have any agents. Everyone can speak the same language. You have this push-based desire state type of architecture. Everything is extensible and modular. You have these thousands of modules you can use, which you can kind of think of it as maybe in a programming language, like a function you can call without actually, writing everything you need to do for Yum. You just call the Yum module and make it a lot more easy to read and also modular with various almost full like you can do a full various different tasks. Like maybe you want to lock down a system. You can call a Ansible role to do that. And there's actually thousands of pre-created roles out there too that you can leverage. So these are kind of reasons why Ansible is a great use case for defensive security. So it's not a zero-sum game. What I mean by that is I'm not saying here get rid of your Nessus scan or get rid of whatever all the tooling that we talked about in the conferences for security automation for the SOC that the various other speakers here are talking about. I'm not saying that. Ansible is the tooling to automate whatever manual tasks that you may be doing from an operations standpoint, from an application lifecycle standpoint, things like that. So how we're going to show this piece is through the demo. This is a demo that Chris created. This is actually a very, very simple playbook. What it's doing is it's just going to, as you can see here, it's just going to use that get URL module right here. And that's actually downloading that malicious file. And then, you can see the permissions that changed here. That's, it's allowing for, basically blanket execution. You're using the shell module to actually do the execution and then, executing that script, and it's making it continuously run, and then we want to have some sort of persistence in place, right? So you want to have it's very common for us to lose our initial attack vector, whether it's through patching, things like that, reboot, right? So in this case, we're creating a new user, as you can see here. The user is attacker, and then this way it's easy for us to identify later on, right? And then we're adding that user to the wheel, which will provide pseudo privileges. Okay, so this is demo time. It's not really demo because you're going to see it in screenshot form. But this is at the high level. What we're doing in the demo is we're going to download that, just like you saw in the playbook just now. We're going to download that reverse shell. We're going to deploy that malicious user, and then we're going to try and take advantage of that fact that we have that privilege escalated user by taking sensitive data, that kind of thing. So this part here is just the setup. So what you're seeing here is So you can see here that the Apache service is set up. This is just to host the actual malicious payload, because you got to put it somewhere. In this case, the malicious payload is it's hosted on a website. In reality, you probably want to put it in some kind of dummy box or put some kind of heavy proxy on it, right? So that you're not, the forensics team is not going to track it back to you, right? Next. The other thing that you'll notice here in the second line there is MS Venom. So this is what's going to allow us for the generation of our malicious payload. And then in this case, what we're doing is we're actually creating a Linux executable file. That's going to be the one that's actually creating that reverse shell interpreter. That's that session back to the attack system, and then we're just generating that file into the web directory. And then here, what we're doing is we're actually executing that playbook that we saw earlier in that first slide. And then after that's done, of course, then where we have that that shell that we're receiving, right? So we successfully ran the playbook, and then attacker receives the shell into the victim system. So now with that, I can do things like, you can see here that Ansible actually deployed our new account on the system. You can see the attacker user down there where the arrow is. This is what we're going to use later for that persistence. Obviously, you probably wouldn't want to use the, in real life, attacker as the user, because that's going to be pretty obvious what you're trying to do there, right? You're probably going to want to use a username that's more or less obvious than what we put here. This is just for demo purposes. You can kind of identify what we did much more easily. And then after this is now the user has priz, right? So finally, not only were we able to create that user, but that user is now able to be put in the wheel, as you see there, which on this server is the group that has access to all those unlimited privileges. So this is obviously for the long term. This is ideal for the long term for privileged access to the system. In some cases, it's possible that the wheel may not have pseudo privileges, and then a custom group may need to be created. So as you can see, Mothership Cat is not amused. The idea is that Ansible again it's allowing us to you can have the ability to blend in, right? You're not doing anything unique. You're SSH, WinRM, that kind of thing, right? So, Ansible's good for even the defensive side piece, with creating very simple type of playbooks to, create that attack on the victim server. Okay, so next, what I wanted to do is move on to the defensive security. Of course, most of our customers are probably asking us about this, like show me how Red Hat can help with the defensive side of the house. This is we have a lot of solutions here as well. So what I'm gonna focus on in terms of defensive security are these 4 use cases. Number 1, configuration compliance. This is Ansible for defensive security. That one is a lot of our customers want to be able to have the automated configuration compliance, and Ansible here it can help with that particular use case. Remediation, incident response, automation at scale. And when I mean automation here, I'm not talking about all the automation that we kind of talked about. Some of the speakers here talked about, like I don't know, so all the threat response and centralized logging and all the things that a SOC might want to care about. I'm talking specifically about in terms of OS and application lifecycle, things like that. We actually would provide for that's relevant to our products. And then security as code. So what we're going to do now is we're going to kind of dive into these 4 items in more detail. So let's talk about configuration compliance. So the story here starts with OpenSCAP. This is a tooling that is free and provided with our operating system, Red Hat Enterprise Linux. In addition to many of the other security technologies that's included in Red Hat Enterprise Linux, and when I delivered a lab here as well, and with Roy's help. And the idea here is that there's multiple technologies, and OpenSCAP is one of them. And what it is this is our NIST certified scanner. Like many of you guys may be using Qualys or Nessus or these kinds of scanners. The idea here is that we are giving the tooling right inside RHEL to be able to do security compliance, not only for vulnerabilities, but compliance to baselines, security baselines as well. So that way the Linux admins can be proactive about doing their scanning and remediations before their Qualys or Nessus, these kinds of toolings come into the picture. So this is our tooling that's inside Red Hat Enterprise Linux that does scanning not only for VMs and physical machines, but also container images. what it's doing is not only scanning for vulnerabilities, but as I said, it's actually scanning for compliance to baselines. We ship this content right with inside RHEL. And so the idea here is that if I want to check to see if my system is compliant to DISA-STIG or PCI DSS or the CIS standard or any of these other ones, we actually ship the ability to scan it, and we also ship the ability to remediate as well. So we also ship Red Hat provided and supported Ansible playbooks for compliance to these security baselines. The other thing here is that we also ship a GUI-based tooling called SCAP Workbench. And what this does is not only allows you to do the scanning, but what's more interesting about it is that it allows you to scan, to modify or tailor the content. So let's say in the GUI, I want to be able to load up my DISA-STIG profile, and I want to uncheck rules that don't apply to me, and I want to check ones that do. And then what I'll do is I'll actually spit out the custom content. And and then it'll give you also that automation playbook as well, so the Ansible playbook. So you can actually see this. All of our content is in GitHub. So of course everything we do is upstream. So github.com compliance as code. That's where all the content lives. And again, this is for compliance content for not only SCAP, native SCAP, but also, as you saw, Ansible, standard just bash, and other formats as well. The other thing that you can do with OpenSCAP is not only use the Red Hat provided Ansible playbooks, but we give you the ability in the command line to create your own. So let's say I created some custom, I created like a modified version of the Department of Defense STIG. What I can do is actually generate a custom Ansible playbook from my custom profile. What I can also do is, let's say I've already done a scan. I can actually create a Ansible playbook of just the fixes only. So all the playbooks live in user share, but if you're an Ansible user, of course that's useless, right? Unless it's all Ansible in the Ansible ecosystem. So it is in Galaxy as well. So you can find all of our profiles, all of the remediation in Galaxy. So if you guys wanted to play around with it, it's there. So if you dig in a little deeper, you can see here, this is the C2S profile, which is a version of, it's CIS. We don't use CIS directly. We use C2S because of the fact that they charge for content, so we actually use C2S. We provide C2S. And then here's the HIPAA technical controls. So if we dive into each of these use cases a little bit more in depth, that's what we're going to do now, so you can see how to use this. So the first use case is I'm going to use the Red Hat provided playbooks, right? So in this case, one of the security profile that I'm going to use is called where'd it go? Here, Docker host. The reason I use that is because it's really easy to demo. I'm just going to look to see if one of the checks it does is it actually checks to see if the Docker service is enabled. So what I'm doing here is I'm just going to disable and stop the service, and then I'm going to scan it. And when I do the scan of that profile, of course it's going to fail because I just disabled and stopped the service, right? So then when I run the playbook, then when I do the scan, then of course it's going to pass because that playbook just remediated and put that service and started that service again, started and enabled the service again. So that's the first use case. I used Red Hat's provided and supported playbooks, or I could go to, like I said, if you don't, you can also go to Galaxy and get them as well. The second use case is I want to create a brand new playbook from my custom profile. Okay, so in this case. Again, I'm going to stop and disable the service. And what I can do is I can say generate fix. And I'm going to say name that new playbook profile fix. And then I use that new playbook to run my remediation. Now I can do the same thing in the GUI. I told you this GUI called SCAP Workbench, right? So let's say I loaded up the PCI DSS. Actually, this is the PCI DSS profile. I loaded it up. I unchecked things that are not applicable to me. And then what I can do is I can spit out various remediation content. In this case, like the Ansible content. So I can do it in the GUI or the command line. The last use case is, let's say I've already done a scan. I already have the scan report. And I just want to create a playbook of just the fixes, not everything, just the fixes. So I can also do that. And so that's the last use case. I can do all kinds of fancy things in the command line as well. Like, let's say I want to remediate only high severity rules from this particular playbook, or I want to do things like only remediate rules from this particular policy requirement, or do some other very fancy filtering. I can also do that as well. And then, like I said earlier, like if you had a custom playbook and you wanted to create a playbook of custom profiles that you've changed, so that you've tailored or changed. That's what this use case is. So you can also do that. Now you can do the same thing with container images. Let's say I have a containerized environment, and I want to be able to lock down my container images as well. So in this case, I'm scanning the container image. I can scan that for vulnerabilities, compliance to baselines, and I can lock down that container image by remediating it. So the first use case here is you're actually scanning it for vulnerabilities, right? The second use case here is I'm going to scan that container image for compliance to security baselines. In this case, I'm doing it for the dissystig. And then the last use case is I'm going to lock it down to a particular baseline. So in this case, I'm going to lock it down again to the dissystig, rel7 dissystig. And then it also OpenSCAP also creates reports. So in terms of compliance reports, right? Green light means pass, red light means fail. Here's what it checked for. You can see this is checking for disabling SSH root login. It tells you in words. So it's meant for the auditor and for passing audits. So that's the first use case for configuration compliance. Now, second use case would be incident response and remediations. So in this case, let's say I have a vulnerability. I want to do some patching. In this case, Meltdown and Spectre. This playbook's really easy because I'm just updating packages. I'm using the yum module, and I'm updating various different packages. So let's say that machine or these machines can't be patched, for whatever reason it can't be patched, right? So in that case, I could use something like, in this case, for ShellShock, for example, let's say I can't patch it. Then in this case, I could use I can use SELinux to prevent vulnerabilities like the ShellShock exploitation. And what the SELinux system roles is, this is basically the idea is that these are Ansible roles that we provide inside our operating system to do various automations for configuration. In this case, it's configuring SELinux. So we provide this SELinux system role playbook to do this particular to put the system into to make it configured for SELinux. The other things you can do are things like maybe there are certain CVEs that you want to protect against, and whatever it may be. In this case, you're using the sysETL sysETL module and setting that value to a large number, and that's actually what the fix was for this particular CVE. Or maybe incident response. In this case, there was a customer who didn't really have they made a log aggregator through Ansible, so they used the find modules, they iterated over for our logs and the remote machines, and they put all of that into a local machine using the fetch module. So that's the last use case here is the enterprise security automation at scale. So the story here starts with Ansible Tower. The upstream version of Tower is called AWX. So the idea here is that it's if you want to do Ansible at scale, then you want to use something like Tower because it has things like role-based access control. It has things like centralized logging that tells you exactly when that automation started, who did it, when did it start, when did it end, that kind of thing. You can schedule jobs, you can create automation workflows, you can connect to anything that has a REST API, if you have a CMDB, that kind of thing. So then with that, you can do the use case would be infrastructure and security as code. And so this is where the various different automation workflows can be created. And one of the easiest ones to do is provisioning a lockdown system. So, for example, let's say I could use I can build my system with my code, and I can deploy a existing app, or I could or I could actually provision a completely new machine, or update an existing system. Another thing I can do, another workflow I can do is, let's say I want to do, like I said, provisioning a lockdown system, and the Ansible playbook would look something like this. It would, you would have the provisioning step, but then after provisioning, you can do a bunch of stuff like installing packages, or you can do things like using that Red Hat provided playbooks to lock down that system against a particular SCAP security profile like the Dysys did. If you can also use this workflow, there's a workflow tool inside Tower that allows you to create whatever different automation workflows that you want. You can also, of course, use something like Jenkins to create automation workflows as well. So it's a matter of kind of dragging the Ansible Tower templates. You can see there's a template for mitigating certain CVEs or whatever it may be, and just drag it. And then, if it's true, do this. If it's not true, that kind of thing. So you can kind of build your workflow like that, automation workflow. So the other thing that we introduced is Ansible's integration with third-party security tooling. That's pretty popular security tools out there. That many of them we talked about here. This capability is called Ansible Security Automation. This was tech preview. Currently, it's technology preview. We're going to GA it in early 2019. And what this is it's actually integrations with these third-party security tools like Splunk, Snort, and Checkpoint. So the idea here is that we provide Red Hat created and supported modules and Ansible modules and roles so that you can automate various things that you may be doing in these tools. So, whether it's things like automatically enabling logging or increasing log verbosity across enterprise firewall, or creating new IDS rules to investigate original firewall violation, automatically validating a threat. So these kinds of things where you might want to do with in an automated way, we're giving you tooling to make it easier for you to automate, so that you don't have to write the script to do that. You can just kind of use the modules and the roles and that kind of thing. And so this is just a slide just to show just what I just said in a little bit more detail in terms of the Splunk, Checkpoint, and Snort. So then that's what we're starting out with. But as you saw in this previous slide, there's other security tools out there like secure email, secure web gateways, and threat intelligence platforms. And the idea is that just like we grew the ecosystem for networking with Ansible, we want to do the same thing with security vendors so that we could, again, provide the easy button tooling for automating what you may be doing manually with these third-party security tools. So the last discussion is, how can this be, where is this integration? Where else are these Ansible security automations inside the Red Hat portfolio? And so the idea here is that this when you want to do it at scale in terms of some things like we already kind of talked about infrastructure and security as code, and also maybe you want to do automated patching or various different continuous security and monitoring type tasks, or automated scanning and remediation. So things like that are use cases that maybe you want to do across multiple different systems, across Windows and Linux. And this is where our different management portfolio would come in as well. And so at a high level, if you kind of, so people ask, what are some of the things that these downstream products that's different from the upstream that we have, right? Like what are we doing in RHEL that's different than CentOS or upstream Linux, right? And yes, support is definitely one of the reasons it's different. But there are things we do to the upstream that we do to make it enterprise ready. So like things like, of course, in the upstream, you have to be the one who figures out, are these packages secure? Are they, are these projects, is this actually a live community, an active community, that kind of thing. If you look at something like Kubernetes, if you read about that Tesla hack with the Kubernetes console, how would you know, as somebody who's not leaders in the Kubernetes community, that was actually the console was that you actually have to set up authentication and things like that. So these kinds of things that is where we're giving our customers that easy button is the idea, is what I'm trying to say. Basically, we are very picky about what packages ends up in our downstream products, and we do all these other stuff like QE and automated inspection and signing and secure distribution, that kind of thing. And then so Ansible is integrated into our management portfolio as well. So everything from the system to manage Red Hat systems at scale, whether it may be for patching or whether it may be our AI and ML product, which that's what this is. And this is that's the idea, is that with knowledge that we have, whether from its support tickets or customer support portal, customer tickets, and also our product security team, we can tell like what's wrong with the system. So for example, let's say I can actually see across the board the systems that may be vulnerable to have certain kind of vulnerabilities or certain sort of security problems, performance problems, or configuration issues. Like in this case, you can see OpenSSH vulnerable to remote password guessing attack. And then when I see those issues, I can actually create an Ansible playbook for that particular issue or every issue that was found for that particular system or group of systems. And then what I can do is I can run the playbook right there, or I can just download that playbook and then use it for later. If I have something like Ansible Tower, that information is also inside Ansible Tower. So I can go into Ansible Tower. So Red Hat Insights is integrated with both Satellite and Tower, or you can actually get it right from the customer portal. And so the idea here is that I can see these kinds of security or performance and configuration issues from Tower, and then I can download the playbooks from Insights, which is from the customer portal version of Insights. And then once I do that, then I can actually launch my remediations at scale across all of my different hosts that I'm defining here. And then, as I said, in the log, you'll find things like who launched that remediation. When was it launched? When did it start? When did it end? That kind of thing. So that centralized logs, we see our customers using it for various different auditing type of tasks. Now, Red Hat Insights can also look into our container platform. Our container platform is called OPENSHIFT, and the idea is that it's proactive about finding issues in our container platform as well. And then once we find it, we do the same thing. You can actually create Ansible playbooks from it and then launch it. And then we're also, the other way you see Ansible is automations is also through our various other SaaS offerings that we're enhancing, such as a vulnerability management as a service, and the ability to remediate as in these management service offerings, and then also compliance management as a service. So some examples in terms of, this is the last thing I'll talk about, and that is how our actual customers, what are some examples of some actual implementations. So for example, this is a customer, food and beverage customer. You can see that what they used Ansible for was for consistent and automated patching. And what they had previous to Ansible was they had, their patch process was disjoint. They had one way of doing it in Windows and another way of doing it for Linux. What they used Ansible for is that consistent way of doing automated and controlled patch management. The next use case is security compliance across systems and devices. So as I said, Ansible is not just for Linux; it's also for Windows systems, and it's also for devices like networking devices. And so what they did here is this is a financial sector customer. What they had here was they had a corporate initiative to bring multiple different OSs, so Windows, Linux, Solaris, AIX, into compliance, specifically the U.S. Department of Defense STIG. And also they had various different Cisco devices they wanted to put into compliance as well. And that was their use case for Ansible. Last use case is this is a government customer. They wanted to do what I showed earlier, the security provisioning security compliant host. And they wanted to do that in a more automated self-service type fashion. and create a workflow for that, and just like I showed you in a few slides. So that's what this government customer did. And you can see this was a huge implementation, 100,000 plus nodes. So that's pretty much what I had in terms of like, I just put this as reference in terms of if you wanted to look at things like training, you know, where you can go for training in terms of more information with product security and those GitHub pages with the compliance baselines I talked about and the Ansible playbooks in Ansible Galaxy, they're all here. There's also security labs that the RHEL security lab the Red Hat Enterprise Linux security lab that I did here. All that documentation is also on GitHub as well in terms of, and also various other documentation on redhat.com. Did you have any questions for me? Okay, I guess not then. Thank you for your time. Hope that was helpful.